Okay. So some more concepts like today I will show the transformations. Let's see, I can cover theory because some internet, some in my other system where I can show the demo. Okay. So meanwhile, I start some theoretical part more. Okay. So you guys are able to see my screen, right? Okay. Okay. So last time I showed the word count program where we seen the transformations, flat map, filter, right? These kind of transformations. So today I will talk about some joins, right? These are very important in the Spark. So there are the different types of joins are there in the Spark. So one type of category of joins is simple joins, right? So we already know about the joins because we have already used the joins in the SQL databases and Hive. Okay, the same joins are here also in the Spark. So one join is like inner join, left outer join, left outer join, left outer, right outer, full outer, and cross join, self join, self join. So these are the join categories for the simple join. Other one is spatial joins are there. So we call it joining strategies. So Spark joining strategies, Spark joining strategies. So basically the join is like a query, right? We write for more than 2 data set, right? Sometimes like 2 or sometimes more than 2. So it could have any number of data set, but it will be more than 1, right? Then the join is needed. So how can we shuffle the data, right? So there is a one process is like we are using some white transformation. So there are the 2 types of transformations are there. One is narrow transformation. So narrow transformation, we have some transformation functions are there. We already seen map, flat map, filter. These are the narrow transformation. And when I talk about the white transformation, so white transformation we have group by key, reduce by key, and join. Okay, so these are the white transformation. So group by key and reduce by key, these can be used. Group by key and reduce by key, these can be applied on one single data set or more than one data set. Okay, so group by key is like when I have a key value pair. Okay, I say hello comma 1, hello comma 1. Someone is asking. So when I say hello comma 1, hi comma 1, okay. So when the key is repeated, so I can use either group by key or reduce by key, and then I can do the shuffling, and after the shuffling, I can get the aggregated result. So my result will be hello comma 2 and hi comma 1. So this will be the result, right? So this is my word count result. But here I'm not using the 2 data set. I'm using only one single data set. But this white transformation is doing shuffling. Another approach of the shuffling is, so why shuffling is needed? Okay, if we go first understand why we need shuffling. So shuffling is like we can shuffle the data across the data set and we can perform some aggregation results, right? We can perform some aggregation functions we can apply and then we can get the result, right? So shuffling is important to shuffle the data, okay, across the same data set, across the partitions in multiple nodes, or we can say shuffle data within different data sets and across partitions. Okay, so this thing is shuffle data across the same data set. The example is a white transformation. Okay, so narrow transformation is this is not shuffling is there, but this is in the within partition is there, within like same data set, but within partitions. Okay, across partition is not there. So here is, we can say shuffling is not needed at all in this narrow transformation. But here in the wide transformation, we have shuffling, and we have shuffling in the joins. So when we talk about the join, the join is the category, right? More than one data set we want to join on some particular key, right? So I have a two data set. I say data set 1 and data set 2. Okay. And here is a ID column is there. And here is also ID column is there. And on basis of this ID column, I can apply any type of join. It could be an inner join. It could be a left, right, full outer join, cross join, self join. So I can perform join. Another type of joins are there, that is Spark joining strategies. So what is a Spark join strategies? So these are the three are there. One is broadcast join. Second one is shuffle hash join. And one is sort merge join. Okay. So these are the special joining strategies are there. So if we want to use simple join, we will use either of these any one, or we want to joining strategies, like we can use. So here is a special use case is there. For any one of these three, we have to use any one of these three special join. So we have to find a very special use case. Like here is a small data set which can fit into the memory. We can go for broadcast join. So we know, right, in the MapReduce, we seen that distributed cache. So distributed cache concept in MapReduce, same thing is here also. Okay. In Hive, we have map site join. So similar thing is in the Spark is broadcast join. When one data set, one small data set, which is fit into memory, we can use broadcast join. Okay. Shuffle as join we use when the two data size are equal data. Okay. So when we say two data set with equal size of data, and then we want to do using shuffle hash. So it is using shuffling and then hashing to create a hash key, and then it does the join. Okay, so this is the process is shuffle hash join. Okay, so these joins are there in the Hive also. Shuffle hash join, and broadcast join. So broadcast join we call in Hive is map site join. Okay, so map site join in Hive and broadcast join in Spark, both are same, but these two other joins also there in the Hive. Okay, so now okay, I will show you like how to do join first. Like basically there are the two ways of doing the join. Okay, two ways are the doing join. One is data frame API. So we can do the join. So we use a join function there, df1.join. Okay, so df1 join df2. This is the join function we use for data frame API. Okay, so data frame API we use. Another one approach is Spark SQL. Okay, so Spark SQL is a SQL query. We write a SQL query. Write SQL query in Spark. SQL query. Write SQL query in Spark. That is called Spark SQL. So for this approach, like I have some data frame. So I have to create replace temp view. So some table I have to create first. Create or replace temp view. And I pass some alias T1. Okay. And then I write spark.sql and bracket double quote. I write a SQL query like select star from T1. Okay. So writing SQL is easier than the data frame API, because data frame API, if you are doing any join, so it's like multiple parts are there, and you are like adding those parts, and then you are doing the join. But here is you can complete. Suppose you want to do filter as well, write a join query. Everything you can write in a single select query. Okay, I'll show the some example. There we can see how to write a data frame join and how to write a Spark SQL. Okay.
One question here, Arvin. Can
Yeah.
you give us information about the data frame? Is it the data frame that whenever you're pulling data using API, and then let's say you're using a Spark or Python script, so you can actually dump the data there, and then after that you can parse it somewhere else?
So yeah, so basically this data frame which I'm applying the Spark SQL, I have read this data from some source, right? So this data frame may come from any source, like it could be a CSV file, JSON file, XML file, Spark-K, ORC, Avro, any file or any SQL database, no SQL database. So I have already told, like whenever you are reading data from these kind of sources, you get directly the data frame. And once you get the data frame, then what is the purpose of the like join or SQL you are doing? So like SQL you are applying to do more analytics, right? Basically, suppose you get the data frame, okay, and then you want to do filter, join. The transformation purpose is to conversion of the data one form to another form. So initially, suppose you have an employee data set, you read this employee file, or you got data from employee table in some SQL database. This is one more example. Or you are reading data from NoSQL DB Mongo, NoSQL DB Mongo database. Okay. So either way, you are reading the data, either file or this one, everyone is giving the data frame. That's for sure, because it is already designed, right? So all these are having structured data, right? If you say file you are reading, so there is some columns are there, so schema is there. If I say SQL database, so there is a data types and schema is there. That is the reason you are getting a proper data frame, and that is a structured type of data frame. Schema is attached. NoSQL also when you are reading, so you are having some column data types are there, right? So when you say you are reading a text file, you will not get the data frame, because here is no fixed column. Here are the 3 values. Here are 4 values are there. Here are 10 values are there. So there is no fixed schema, right? There is no fixed number of columns, right? So this kind of text file you are reading, you will get the RDD, correct? But when you are reading the data from any file, SQL database, NoSQL database, anywhere, like you read Elasticsearch, you will get data frame, okay? Because all are structured, okay? So when you read the data, ultimately you will get the data frame. You will get data frame. And this data frame is a tabular representation of the data. So actual meaning of the data frame is, it is tabular representation of data. Tabular representation of data in the form of row and column. Okay. So row and column combination means like you have certain rows, you have certain columns, and then you can query your column and then you can get the result. Same thing you do in SQL also. So you are writing here the field, right? You say ID, name, age, city. So these are the columns, right? So ultimately you are applying your transformation on columns and creating a new columns, or you are modifying the same column while select, right? And that data you can write to the some other target database, okay, or target files, or target NoSQL database. So this is all called ETL. So ETL meaning is extract, transform, load. So one place from one source, you are extracting data, then transforming data, and finally loading data, transform data to target database or files anywhere. Okay, so this process is called, and this is the manual ETL. You are writing ETL manually, like ETL code you are writing manually. Some tools you can use. There is a Talent, Informatica. So these are the tools, right? You can use a tool and drag and drop. You can create component. It's like a wizard. Okay, but if you are using Talent or this Informatica, These are a ready-made tool, but more customization you can't do. More customization of data you can't do. So whatever component, like for the customization, like transformation they provided, you have to use those one. But Spark you are using for ETL. When you are using Spark for ETL, so you can do more transformations, customization you can do, right? You can write your own customized code, you can write, like you can write functions, and those functions you can call at the runtime. Okay, so that kind of customization. Okay, so I just take an example of joins. Okay, so I am just taking a one employee data set and one department data set. Okay, so employee I have EMP ID, EMP name, and EMP salary. Okay, and department I say department ID, and here is also department is there. So one joining column I needed, otherwise I cannot do join. Okay, the department ID and department name. Okay, now I say I want to display all employees with their department name. So we know this is a simple inner join, right? So I want to display all employees with their department name. Okay, so first we look at how to do in data frame API. So first I will read the data. So well, I'm reading EMP data set spark.read.csv. So I'm assuming these are the two CSV files. So in interviews also they ask question like this. They have given you two data set. They told, okay, this is the one data set EMP and this is the one data set department, and these are the two CSV files. These are two CSV files. So first you have to create a data frame, and you have to read a CSV file by using this, and then you have to pass the file path. So suppose I'm saying this file name is EMP CSV, and the second file is, and this is a Spark Scala code. Okay, same thing we can do PySpark. The only syntax like here, well and where we don't write, but other things will remain same. So DAPT, I'm reading a department data frame, spark.read.csv. So first you have to show them that you have read two files and created a data frame. Okay, now, so first I'm showing you the data frame API. Okay, data frame API. Later I will go for Spark SQL. Okay, so I had two data frame. Okay, one is a EMP, one is a department. So now I will write well join data frame, some name I given, and now I'm taking first data frame is EMP dot join department. In the bracket I will write department. Then I will say EMP of ID, EMP of DPT ID of equal DPT of DPT ID. This is the joining column. Okay, and what is the type of join? Inner. So this is, I'm writing a data frame API. So data frame API is using the function way we are writing. We are writing the join using the function, the join function. Like it's a transformation here. Join is a transformation here. Okay, so join function is a transformation here. White transformation. So when I write this one, suppose I take some data. I say EMP data has ID, name, salary, and department ID 101, 2, test 1, 4000, 101, 3, test 2, 8000, and 102. I take two department. So my data in the department is 101, HR, 102, admin, 103, payroll. Okay, but you can see here 103 department, no data is there. Okay, I will tell you this use case scenario will come how to do left join. Okay, so we want some information which is not present in one data frame, present in other data frame. So here you can see join DF I'm writing. So what my result here? So here is the inner join. So one is matching. This 101 is 101 matching. 101 is matching 101. Again 102 is matching 102. So total number of record, how many records should come? When I display this result here, so I will get 101 and 101 I will get HR, here HR, and here I will get admin. So this 103 is not matching. So inner join case, in this inner join, the data will not come. So when I will do join TF dot show, so this will be my result. But you know, whenever you are doing the join, so your extra column ID will be coming 2 times, this department ID, because department ID is a part of your employee as well as department. So you will see 101 coming 2 times, 101, again 101 and 102. So department ID will be coming 2 times, one for inner, one for employee and one for department. So here I have to drop that column because I don't want to show this department ID 2 times. So I will say drop off column of EMP of department ID. Anyone you can drop because both are same. So EMP of DPT ID. So this column I will drop it. So I will get only 1 column. Okay, so this only department ID of department table will come. So this is my inner join. This is data frame API. Okay, so this is the data frame API. I have done the inner join. Okay, now I say if I want to write the same thing, if I want to write same thing through Spark SQL, so how to write? So I have to get the same result. I have to get the same result, but I have to use Spark SQL. Okay, Spark SQL. So in Spark SQL, I will read data frame. I will get the data frame, but after this, I will create the temp view. So I have shown here, like create temp view. I will create. So I will write EMP create or replace temp view, and I just give the name E. Okay, some alias we have to give E. Okay, and here I'm giving alias D. Okay, so actual table name will be this one, whatever alias I'm giving, and this is DPT. Okay, and now I will not write this. This is a data frame API. So I will be writing a Spark SQL. So how I will write spark.sql, and in bracket I will write select. Okay, so first I have to do both the one E join D on E dot DPT ID equal to T dot DPT ID. Okay, and here I have to select the field. So here is a choice, like you can, whatever you want to select, you can do. But here is whatever is coming, it will come, but you have to drop. Okay, so here all the columns will come. All the columns will come. Both side column will come, but then you have to drop the column manually. Okay, but here it's a choice, like when you are doing the join using the Spark SQL. So you can select the column, whatever column you want. You say, okay, I want EMP ID, E dot EMP name, E dot salary. I want D dot department ID or DPT name, DPT ID, D dot DPT name. So this is a Spark SQL. So like this, we write a simple Spark SQL. So whenever we are going to write either any join, so in two ways we can do, either this way or this way. Okay, so this will be giving also the same result. This is just only a different way. And even this Spark SQL is converting into the data frame. So data frame API is faster than the SQL, because actual API is a data frame API only. But when we write SQL, it is converting into data frame and then it will get the result. Okay. Now, how to use a left join? Okay, suppose I say one requirement here. I want all employee, no matter what is the department. Okay, so in this case, the inner join result will come because I want all employees. If I ask you in a different way, I want all department with their employee. So in that case, how many records should come and which record will come here out of this data? If I say all department with their employee. So in this case, I cannot use inner join, right? Because when I'm talking about all data set of one side, it means left outer or right outer. So when I say right side all data I want, no matter how many employees are there in the left side, okay, whatever matching is there, that should come, okay. But I want according to the one side of all data, either left or right, okay. So if I say all data of employees I want, so it will give the same result of the inner join, because when I take 1, 2, 3, and here is a 101, 101 matching with HR and 102 is matching with admin. Okay, so there will payroll will not come. But when I say right side all data, okay, right side all data means then 101, 102, 103 will come. But 103, there is no corresponding data in the left side. In that case, the null values will come. Okay, so all data will come null. So when I say left outer join and right outer join, so left outer join, so left side table, all data, left side table, all data, and right side matching data, right side matching data, and non-matching data null. Non-matching data will come null. Okay, so this will be, so right side non-matching data will come null. So that is a property of left side join, left outer join. When I say right outer join, so right side all data, and left side matching data, whatever matching is there, matching data will come. Left side matching data and non-matching from the left side null. Non-matching data will come null. It's a reverse of left outer. Okay. So if I'm doing, it depends what table you want to keep it on the left side. Okay. So same thing we will use here. Only thing is I will change here the join type is left outer. Okay. So when I'm writing join, so first of all, I will read the data frame and I will use here left underscore outer when we are using the joining, when we are using the data frame API, left outer. Okay. When we are writing SQL, so in SQL, here we are using simple join or inner join. So here I will use left keyword. Okay, like this I will change. Okay, so when I do this left outer, I kept it employee left side and department right side. So as per this, the same result will come. Okay, because all are the data matching is there. No matching data is not there. Okay, but if I change this SQL here, I do reverse. If I do left side, I keep it department, and right side I keep it employee. Okay, here is nothing difference, both are equal only. And here I do left outer and I will drop this column. So I say here, so what data will be coming? Left side is 101 HR, 102 admin, and 103 payroll. So this will come, right? Because left side this 101 HR, which record is matching? This one is matching, right? Contest 300. It's a matching data of the this one. Okay, I have one more is there, right? So one more is there, so this will come with another one entry of 101. So I will say the entry is this entry. Okay, and this is the third one entry, this one 102, but here is no entry, so it will come null, null, null. So all values of coming null. But here is the requirement is I want all the department with their associated employee. Or I can say one more example in the order and customer. Okay, I have a customer and order data set. Suppose somebody is asking you query. Somebody is asking the query simple like one customer has one order or two order, and I want to find all total orders, or all customer with their orders. So inner join will go. I say I want to find all those customers who have not done any order, who have not done any order. How to find those customers who have not done any order? So basically I'm looking for this kind of data where null is there. In the order side, null is there. So how to get it this data? Only null data I want to get it. So I will check this ID column is null is here, right? The department ID column null, right? So some matching column will be there, that will be null, right? So I will be writing a query, select, okay, from order O, left outer join. Okay, first I take customer. Left side I have to keep customer because I have to find those customer. So first I have to check all customers. I have to find all customer, order or not order. All customers with order, with orders and not orders. Okay, so that combination will come. All customer means with order or not order, right? So what I will do, whichever is a not order one, I will select it with the condition. Okay, so same thing I'm doing. Customers, C, orders. Okay, left join, order O. And what is the key on C dot order ID? This is a joining column. O dot order ID. Okay, and I say and condition, I say order ID is null. If I give it this one, so you will get only this. If you don't give this order ID null, all will come. All with having order or having not order, all will come. But when you give order ID not null, so these will come. Okay, so what are the field I will select here? C dot customer ID, C dot customer name, and O dot order ID, O dot order amount. Okay, like this, I want to just display the customer with their order amount, Okay, so I need to use order ID is null. This is the way I have to find the customer. So this left join is very useful when I want to find all customer, no matter they have done order or not. So in that case, you will not put this condition. You will get all customers, whether they have done order or whether they have not done order. That is a pure left join. But they are asking, I want to find only those customers they have done order. Okay, only they have done order, like not. So here you will put not equal to null. And if you want to find the customers they have not done order, so you will do it order ID equal null. So this is the only change you will do. Your result of query will change. Either you want this, either you want this, right? So you have to change this condition. If you don't give this condition, this all will come. Okay. So here is a left join, but Spark has given one join, left anti and left semi join. Okay. Hive also having the same join. Spark has given for this purpose, right? This particular purpose, like you want only orders are there or orders are not there. For this purpose, Spark has given left semi and left anti. Okay. So anti meaning you can understand. Anti meaning is something is there in the one data set, something is there in one, but not in the second. That is anti. Like this kind of thing, like this. Something you want which is present in the one, but present also in the second. That is your semi. Okay. So, okay. So suppose if I want to apply left semi join on this. Okay. So I have a two data frame. Okay. So I want to apply left semi and left anti. But one problem with the left semi left anti is it gives only left side data. Suppose you want to get the combination of both. Okay. So you cannot get the both data. Okay. Because like some record which is matching from left to right and you want both the data, you can't do with the left semi left anti, only left side part of the data it will give. It will find whatever matching or non-matching from the right side, but it will give you only left side data. So if you want both side data, you want generally the this null case you don't want, because everything is null, then what is the sense? Okay. So left anti case is fine. Okay. But suppose some record which is matching from left to right, so right side data is also important. Okay. So in that case, we cannot go with this left semi. Okay. So what this left semi will do, when I do here left semi, okay. So just I'm doing left semi, and what left semi will do in this scenario, what is the data is matching? Okay. Okay. What is the data matching from left to right? 101 is matching, 102 matching. Okay. So these two rows will come. Okay. So only left side part data will come. Left side part is this much part. This part will come in the left semi. So this is I'm using left semi. And when I do the data frame, so I will get this data. So I will get the left side data. So I will get EMP ID, EMP name, EMP salary, and department ID. So I will get left side part, and that part will be the this data. If I do the same result set, if I do left anti, so when I do left anti, if I'm saying I just want only customer information, I'm not bother about the order detail, or I say department detail. Okay. I just want employee name. I want to just employee name, which are the employees who are not present in the second data set. Okay. So this is my requirement. I want those who are not present. Okay. So all employees are present here, right? If I say employee with the department, all are present. But suppose if I add some new data, if I add some data which is not having any department. Okay. So if I say here is one more line, and I say here 4, there's 3, and I say 105. So this department is not present, right? Okay. So this department is not present here. So I'm interested for this record only. The record, the employee who is not associated with any department. This is left anti case. Okay. I can do the same thing with the left join, and I will put the department ID equal to null. I will get it. Only this record I can get it by left join also. Okay. But I want to use the left anti. So when I do left anti here, this left anti, so what will be my result? I will get only one record. I will get this record only. And only left side data I will get it. So I will do this result. So my result will be only this row. So this is clear, right? Like same thing. So you can say left outer is a combination of left semi and left anti, but right side data is not there. Okay. And left outer is giving both side data, but it is taking left side all data. Okay. So same thing like right side join right outer join I do. So right side all data will come. Okay. Right side all data, and whatever matching will come, and non-matching will come null. Okay. Is this clear? This one, this joining, right? So this are the left, right outer join. Self join. Self join is like when you do the join itself from that same table. Okay, so first of all, what is the need of self join? Which scenario you should go for the self join? Suppose I'm saying I have an EMP table, and EMP table has EMP ID, EMP name, salary, and manager ID. Manager ID. So every employee has the manager. Okay, one test salary something manager ID. I say 1 2. Okay, and this is a 2. The same manager is again an employee. Okay, test 1 from salary, and his manager is 3. Okay, so I say here 3, and then test 2, then this is 1. Okay, so this is like a data set. So I say this employee ID has manager 2, this manager again an employee who has a manager 3, and 3 is the manager employee, and the manager is 1. Okay, okay, so I want to compare the salaries. I want to say, okay, I want to see like salaries, like employee salary is more than the manager salary. So employee has the more salary than manager salary. So if I want to get it, so suppose I say for this employee, okay, who is the manager? 2. So 2 is having the 7890, and employee is having a salary 6788. So this is not a case, right? So it will not come. Okay, suppose if I make it 5000, then it will become the case. So when I say this case, so employee has the more than salary of his manager. So this record will come. Okay, so I say employee, I want to print with their salary. So 6788. Okay, and now this 2 has manager this. So manager salary is more. Okay, so I just change here. I will make it 4000. So this guy will come also, right? Okay, and if I compare this employee 3, employee ID 3, and whose manager is 1, so 4000 and 6788. So 4000, 6788 is greater than, right? So manager salary is greater, so it will not come. Okay, so these 2 record will come. Okay, so we want to display this. So my requirement is I want to compare the record itself in the same table. Okay, 2 record I want to compare. So I need to use self join and compare the record and get the result. Okay, so I will how to use the self join. So select, so 2 alias I have to create emp e and join emp m manager. Okay, and I say here e dot manager id e dot m dot employee id. Okay, like this 2 and 2, 3 and 3, 1 and 1, like this. Okay, and I will say this is on. Actually here on will come whenever we are matching. Okay, and then I will give the condition here where, okay, I want to say e dot salary greater than m dot salary. When I say this, so I will select here the field e dot employee ID, e dot employee name, and e dot salary. And if you want to print the manager, so manager ID also we can print who is the manager. But I want to just display this information where the salary is only those record. So this third one will not come. So this kind of data you can do self join. So this kind, sometimes they ask how many reportees are there for a particular manager. So in this scenario, I will say every manager has one reportee. Okay, so this one is, the manager is 2, so 1 reportee is there. This manager is 3. Okay, so he has 1 reportee, and this one, so all are 1. So I want to find the number of reportees count who are reporting to the manager. Okay, so this kind of requirement you can do with the, so you have to use group by things, and then you have to use count function. Okay, so you can use group by on the manager ID. Okay, so employees who are associated with the same manager, then you can do the group by, but you have to do the self join. So in the self join, because the table is the same, so you have to do group by option. Okay, you can use select E dot employee ID. Okay, manager ID, because manager I want to find the count manager ID, and then you say count function of E dot EMPID, right? From EMPE join EMPM on E dot, same thing will come manager ID M dot EMPID group by you will do on M dot E dot manager ID, because manager ID we want to do grouping. Okay, so because this is like whatever column you are doing in the select, that should be a group by column. Okay, otherwise we cannot do. Okay, so E dot manager ID, same column in the group by. Suppose I say having count. Okay, I say I want to find those manager who have more than 5 reportees. Okay, so I will put extra condition here, having count of E dot EMPID greater than 5. So we know, right, when we should use having and when we should use where. Where is used when we want to do any condition on column without the column who are not part of the group by. So which columns are not part of the group by? See, EMP is the part of the, so salary column I can use on the where, manager ID I can use in the where, and EMP name I can use in the where. But I cannot use EMP ID on the where clause, I cannot use. So if I have to do any condition on the group by aggregate functions, so I have to use having clause. So something I want to check on the result of aggregate function, I want to apply condition, I have to use having, I cannot use where. So where and having can come together also, but depend on the need. Okay, suppose I say I want to find employees who are in some certain department. Okay, so here I will put a where clause after from table where I say E dot EMP department ID. Okay, some certain department name I'm saying, department ID 101. So in clause we know it will check. So only 101, suppose I say 101, 102. So even some employee who is the manager who is qualifying this criteria, having criteria, like he has 5 reportees. Okay, but still it cannot come because his department is not matching. So if you want to do, but department ID column is not there, or I can say some other column condition. I can say the salary is in between, where salary between, like I can say range. Okay, 1,000 and 5,000. So anywhere condition you can put. Okay, whatever columns are there, 3,000. So all are the in between, it will come, otherwise it will not come. Is it clear? This one, this is like a self join scenarios, like when you will use the self join. Another join is a cross join. Cross join is when you are doing multiply of the record of the both the table. So I say my employee table has 3 record and department is 4 record or 2 record. Okay, so total number of record will be coming 6. That 3 multiplied 2. So 3 multiplied 2 equal to 6. So all combination will come, like one employee with all 2 department, the second employee with 2 department. Okay, so like this combination will come. Okay, so that is cross join. Okay, so generally cross join is when I want to make a combinations from 2 different data sets, so then I will go cross join. Otherwise mostly I will not use the cross join. Okay, so I'm telling the where you can see the examples of the these joins. Okay, Spark. Okay, so this is having all the shuffle join, these join are there, bucket join is there. Here is a simple inner join, left outer. Check it. By actually. Okay. Or you can go this website, both are there. Spark one, Spark Scala and PySpark. Okay. So this, whatever I taught today, this inner join, full outer join, I forgot. Full outer join is a combination of left outer or right outer. Okay. So either you can go for equivalent SQL join, SQL you can use. Left anti-left semi you cannot use in the SQL query. Okay. So that is only in the data frame API. Okay. Not equivalent SQL join. Okay. So in the SQL databases, you will not get this left anti and left semi. Okay. Just remember it. This left semi, left anti is in Hive and Spark. Okay. So it's like, suppose some example is there. This is the data set. Okay. This is the employee data set. And department data set is there. So they are finding the inner join, left outer join. So here is the scenario. Full outer join, which is a combination of left and right. So here both side null will come. So in full outer join, if I do it here, in my case, if I say, so like whoever employee is matching, the right side matching data will come, not matching, null will come. And department also, right side all department will come, but left side is a employee is not matching with the department, so it will come null. So suppose if I do full outer join for this, full outer join, so just I need to change here. I can use full underscore outer, and when I do the join in this one, full outer, so all left side data and matching will come 101, like this one, HR, here is HR and admin. So 105, there is no department, null will come. Okay. And here, when I say 101, 102 is coming, but payroll one is not coming. So this side, here is null, 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 and then right side data. So this combination is a full outer. So this part is a left outer and this part is a right outer, right side. So here is a right side all data. So right side all data means HR, admin, payroll, all three are coming. Okay. And whatever is not matching, null is coming, and matching, this matching data is coming. Same thing is the left outer. Left outer is left side all data is coming in the full outer, and whatever is not matching in the right side, that is coming null. So this is the case full outer. Okay. So this one is a full outer join. Left outer, right outer, left semi. Left semi means matching. Left to right is matching, but only left side data. Whatever matching data from the right, but only left side data. Okay. So this data should be your left table, not right side data. Left anti, non-matching data from left to right, non-matching. Self join, when the like a table itself, like the same table, and I want to do, I can use the self join. Okay. So this complete code, either you can run in the IntelliJ IDE, you can create a one class object you can create, and then we can do it in the because we don't need to read any file, because this all data is in the one file. So we can, okay, I check, I can do in my IntelliJ. I can create a one Spark Scala project, but I need to have some jars like Maven dependency. So I have to create some Spark Scala Maven project. Their Spark dependency jars I need in my Maven project, Spark Scala Maven project, and then I can create an object and I can run the code. So how to create a Maven project? So it's simple here, right? Any Java project you can create first, and then you can add the Scala dependency. So new, you can go, you can create a project, or you can take it from the GitHub also. So new project, Spark Scala. I think IntelliJ. So some workspace I have to select. Okay, it is not created a form project. So like this form project should be there. So this is, here I have to create my new object. So I can keep it same name, whatever name is here. Join example. So all practice you can do, like here I have to create a Scala class, and it should be object type. So in Scala, we have to create an object, and this object is my main function, main program. It should be a main function. So this entire code, this package, I remove it because I'm not using any package. So this is POM is having this dependency. Spark core. This is a dependency I needed. Spark core and Spark SQL, two module I need. Okay. So it is giving error. So I have to reload. Even we can read the data from some file also, like department or EMP, you can create in the resource. Some file you can create, new file, and you can create emp.csv. And this data, we can copy it there. That data like we have created in the notepad. So this data, we can put it out there. So like this, we can also read the data from the file. If I don't want to create my own data, so we can do. Need to check the Java version. Project setting. 0.8. File project structure. Here is global library, Scala library, SDK is a Java. Okay. So we are using 1.8. An error coming. We even build with the Maven also. So Maven, we can create a clean install. Clean install. Yes. Like it is not picking the jar here. So this all jars will be, the compilation error will be resolved. This form is fine. I think here it is. It will give the suggestion here, right? Once this build issues error resolved. So this way you have to create a program and then we can run. So we'll get the whatever output of all these join, right? We are using this different joins. This is not a join, this is all filter thing. So I copied the wrong one. So we have to do all the different joins like these joins. So you can copy paste and then we can try. Okay. Okay, I'll show it on Monday. Okay, so meanwhile, you just go through the concept. I will send this notepad file. Okay, so this join are very important for Hive, SQL, or Spark. Okay, but just remember Spark and Hive is having the left semi and left anti. Okay, so Hive and other SQL databases not having this join. Okay, so anyone has any question? Okay, thanks everyone. End session.
Yeah, thanks.
Thank you, Arvind.
Thank you.
Thank you.
Thank you, sir.